Welcome to solverfy.
This problem we're trying to figure out the pressure of ammonia under certain conditions. Just write ammonia up here. We're trying to look at the ideal gas law versus the van der Waals equation. The ideal gas law is PV equals nRT, a very simple equation, and van der Waals essentially builds on that. We get P plus n squared A over V squared, V minus NB equals nRT. The van der Waals suggests the pressure term to include a term for interparticle interactions. And V minus NB, this term has to do with adjusting the volume to account for the volume of the particles, because an ideal gas, we assume, doesn't really have mass nor volume. So looking at the info that we have, we know the mass of the ammonia. We know volume, temperature. We have two temperatures. We actually have to solve it for both. And we know R, which is just a constant. So first thing we want to do is mass doesn't help us here. We need moles. So if you look it up, molar mass of ammonia should be 17.03 grams per mole. If you solve that, you'll find that N actually equals almost exactly 3. So now let's look back at these equations. First, let's just adjust them so we are solving for pressure. So P equals nRT over V. So then adjusting this, we get P plus n squared A over V squared equals nRT over V minus NB. And solving one more time by subtracting that term, we get P equals nRT over V minus NB minus n squared A over V squared. So we're almost ready to solve everything, but there are a few more things we need. First of all, we can't actually solve these equations using degrees Celsius. We actually have to convert them to Kelvin, which is luckily a very easy conversion. So this actually becomes 273 Kelvin, because all you have to do is add 273. So by that logic, this then becomes 673 Kelvin. So we have everything we need to solve for the ideal gas law. But we're still missing something for the van der Waals equation, that is B and A. So in your book, you can look this up. You'll find that A equals 4.17. Oh, run out of room to write the units. Here, I'll write this somewhere else. Find that A is going to equal 4.17 atmosphere liters squared over moles squared. And for B, it is going to be 0.0371 liters per mole. Okay, so with all that info, we can find the pressures. So I won't show us plugging all of them in, but for the ideal gas law, the pressure at 273 K will actually come out to be 22.41 atmospheres. And the pressure at 673K will equal 55.25 atmospheres. So, running out of room, so I'll just have to go ahead. Well, let's not delete these actually, because we're going to want them to compare the answers. So instead, I'll just go ahead and get rid of this portion. So if we solve, I'll just write the equation one more time. P equals nRT over V minus NB minus n squared A over V squared. So for the van der Waals at 273, we should get 19.11 atmospheres, and it's 673 Kelvin. We should get that it is 53.21 atmospheres. And so we can see how this equation will adjust the pressure under these circumstances. Hope this helped all of you.